So we've set up our grids. The 5 bits of information we've added there in red are going to be constant. Excuse me. That's the telephone ringing in the background there. So we've been asked to calculate the time of flight. Well, what additionally can we add in the grids? Well, as the projectile moves, just before it lands, its vertical displacement will be -20. It'll be minus because it's moved downwards. So relative to the start point, if it's moved downwards, that gives us -20. So how do we calculate the time of flight? Well, remember there are 4 Suvat equations, and it's worth you learning these. It takes perhaps 10 minutes to sit down and learn them, and I think it'll make you more confident if you're quickly able to write them down and use them in a projectile problem. So which one do we need to use? Well, let's just have a look back at our grids here. The question is calculate the time of flight. So if we look at our vertical grid here, we've got 3 bits of information, we've got 3 values. Now normally in a grid, especially in a vertical grid, if you have 3 values, you can easily, if you use the equations, calculate the other 2. Not quite so simple with the horizontal, because 2 of them are the same. If you have 3 bits of information, often you can't work out the other values. But for the vertical grid, it'll always be the case, even if 2 of them are the same. If you think it through, as long as you have 3 values, you can always work out the other 2. So we've been asked to calculate t, excuse me, the time of flight. So we have s, u, a, and we need to calculate t. So we need an equation involving s, u, a, and t. If we just look back at our Suvat equations, which one contains s, u, a, and t? It's the first one. So rewrite the first one there. S equals ut plus a half at squared. And looking back at our grid here, we have s is -20, u equals 0, a is -9.81. We've been asked to calculate the time of flight t. So we'll go back to our equation. Often it's easiest to substitute the numbers in first before rearranging, and you'll see why here. And you'll see why, because u, the initial vertical velocity, is 0. What I haven't said here, which I should write next to this, is when you use the Suvat equation, when you write one down in a projectile problem, it's always worth writing down whether you're applying it to the vertical or the horizontal. If you write vertical next to it, it stresses that all this information needs to be vertical. This is the vertical displacement, the initial vertical velocity, the time, the vertical acceleration. Some students, particularly if you don't write down that this is applying to the vertical, sometimes mix and match the vertical and the horizontal. They may, for example, use the initial horizontal velocity in here. But if you write down vertical there, it just makes you think that all these values need to be vertical values. And so we've got our initial, we've got our vertical displacement just before the snowball lands. We've got our initial vertical velocity. We've got our vertical acceleration, since air resistance is being assumed to be 0. Now you can see the benefit here of substituting the values in and not just trying to rearrange this to get t as an algebraic expression. The benefit is that because the initial vertical velocity is 0, we've got 0 times t, so this whole term becomes 0, and that simplifies our equation. If we just minus both sides to make minus minus become a plus, and if I just calculate this with you now, having prepared this in advance, so I'm just going to calculate here the right hand side. 0.5 times 9.81 gives us 4.91, so that becomes 20 equals 4.91 t squared. So t will be 20 divided by 4.91 all square root, which is 2.02 seconds. So there's our time of flight. So if we return back to our original grids, we can now add in response to question 1, the time of flight, and we'll put that into both of our grids.